Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are looking at 7.1 trigonometry ratios. What will we be learning? Well, we will define the three trigonometric ratios, sine, cosine, and tangent, in terms of a right triangle. Why are we doing this? Well, trigonometry helps us find angles and distances, and is used in a lot of science, engineering, video games, and so much more. How will you know you've learned it? Well, you'll know that you've mastered it when you can determine the correct ratio given a specific information about a right triangle.
Well, let's get started. I love this chapter.
You know what? This chapter is even easier than the last chapter.
I agree. All right, so our first trig function that we are going to be looking at is sine. If you remember from our trig introduction, it's really important that you guys are labeling your sides of your triangle using the vocabulary words hypotenuse, opposite, and hypotenuse, and adjacent. Where I always like to start is the hypotenuse because that's always going to be given based on the right triangle. So first, we know that angle C is our right triangle, so we're going to come up here and say that this is our hypotenuse.
Now remember that right angle down in the corner will always point at the hypotenuse. You also need to remember your hypotenuse is always the longest side.
Agree. And then from one of the acute angles, you are going to be labeling your opposite and adjacent side. So in this case, we are going to start using angle A. So angle A will always be opposite the opposite side. So we are going to say BC is our opposite side. And then lastly, our adjacent side is going to be the leg that is right next to the angle you are using. We're using angle A, so leg AC is adjacent to angle A.
Now, the thing that you want to keep in mind here is we could have also used angle B. We will never use angle A.
Never the right angle.
Angle C. Nope.
Never the right angle. It's always going to be the two acute angles.
Had we used angle B, the hypotenuse would still be the hypotenuse.
It would. Oh.
And then our opposite and adjacent would swap spots.
Exactly. And we'll get more into that in the next few problems. You'll see kind of the relationship between using the two different angles. So sine, cosine, and tangent, our trig functions, actually use a lot of the stuff that we were doing in chapter 6. What trigonometry shows us with right triangles is that if you have a right triangle, no matter the size, if their angles are the same, then they are similar to all other right triangles with the angles that are the same. So the product, or I'm sorry, the quotient of dividing two of the sides is always going to produce the same exact number. For sine, what we're doing is we're dividing the opposite and hypotenuse sides, and no matter what size the triangle is, if the angles are the same, the answer is going to be the same. So sine uses that relationship of opposite to hypotenuse to tell us what is that angle in the middle there. So in this case, we're going to be substituting in the angle and what are the sides. So remember, this is theta. So right here after the abbreviation of sine, which is SIN, this is not sin. This is what it will say on your calculator, but again, that is the abbreviation of sine. So this would be read sine of angle theta is equal to the opposite side divided by the hypotenuse side.
Now just keep in mind that theta is the symbol, the Greek symbol that we use in place of an unknown angle measure.
So think of this right here as like your formula for sine. You're going to be substituting in what theta, opposite, and hypotenuse are. And when you're actually finding a missing piece, one of them will remain a variable while the other two become constants. So in this particular diagram here, we are looking or using angle A. So we would substitute angle A in here. And then the opposite side is side BC. And then the hypotenuse side is side AB. So we would plug in and say sine of A is equal to side BC divided by side AB.
Keep in mind, it doesn't matter if you put BC or CB or AB or BA, because these are just line segments and we don't care about the order. It's only directed line segments when we really care about that order.
Correct. All right. The next trig function that we're going to look at is cosine. So I have the same exact diagram here. So our hypotenuse is going to be that same side, that AB side. Again, angle A is marked, so if I use angle A to figure this out, it's going to be using BC as our opposite side. And then lastly, AC is going to be our adjacent side. The cosine ratios are that when you have angle theta, whatever degree it is, for all other right triangles where theta is the same, when you divide the adjacent leg by hypotenuse, it will produce the same exact number. So we are always, for cosine, going to divide adjacent by hypotenuse. So in this particular diagram, cosine of angle A is going to be equal to leg AC divided by leg AB. So there's cosine. And then our third and final one is going to be tangent. Again, the abbreviated version of that is TAN, which is still pronounced tangent. So tangent of angle theta is equal to the opposite leg divided by the adjacent leg. So looking at our same diagram again, we have our opposite side. Looking at angle A, we would say BC is opposite it, and then the leg next to it or adjacent to it would be AC. So in this case, angle theta, we're using angle A, and then opposite to adjacent would become BC over AC. I'm sure many of you have heard the, is it mnemonic device?
Yep.
SOHCAHTOA. You've probably heard a lot of students that have taken geometry, or maybe you've heard SOHCAHTOA before. It's imperative that you guys do spell it correctly. I have it written down the side of each of these pages. The way I actually like to write it is for this first one, O over H. Write it as S and then O over H. And then for the next one, it's C and then an A over an H. And then, oops, wrong way, T with an O over an H. So SOHCAHTOA. Learn that, memorize that. That is basically telling you exactly how to set up your equations.
Agreed.
All right. So next we're just going to baby steps into the next step. Now we're going to introduce the whole idea of numbers. So I would recommend doing the left column on the back side of your notes in 2 different colors because you're going to be labeling opposite, adjacent, and hypotenuse from the 2 different acute angles. So the first one we're going to look at is L, and then the second one is H. Again, we're not going to use angle S because that is our right angle. So we never use our right angle.
I would recommend definitely having multiple colors here because we're going to look at the sine of L, and then we're also going to look at the sine of H. So since we're going to be labeling all of our sides with an O, H, and an A, did you already say that?
I literally just said that.
Well, this is for the people who need to hear it twice.
Oh, okay.
So when we label our sides with an O, H, and an A, you have them in 2 different colors. Oh my gosh, what is wrong with me?
You maybe subconsciously heard me say that.
Did I?
Or maybe we're just that brilliant and think that much alike, because I think I said literally the same thing.
Genius.
Genius. All right, so from L, you're going to label O, A, and H. H is going to always be the easiest one because it's the hypotenuse of the right triangle. So that's going to be out here by the 13. From angle L, if you go through the triangle to the opposite side, you'll see down at the bottom that that is our opposite side, whereas 12 will be the adjacent. So sine, if you flip your notes back over and remind yourself about SOHCAHTOA, the SO part is spelled S-O-H. So we are looking at only O and H. So in this case, our opposite to hypotenuse ratio is going to be 5 to 13. Now here's where the second color comes in. I would now do the same exact thing but from angle H in a second different color. So from angle H, 13 is still my hypotenuse, but now the 12 is opposite and the 5 is adjacent. So the sine of angle H is 12 over 13. So as easy as this seems, I cannot stress this enough, we both require you to label the opposite, adjacent, and hypotenuse sides every single time you are doing these. What I want to bring to your attention is that if it is labeled incorrectly, you get 2 very different answers. So it's really important that you get in the habit of labeling and taking your time, because sometimes things that seem very easy, you can easily make mistakes too. So please focus on where would opposite go, where would adjacent go, where would hypotenuse go, and then set up your sine, cosine, or tangent.
Now, I've told my students on every single problem I should see the O, the H, and the A, like we have just said, and I actually want to see the angle marked with the arrow going to the opposite side.
Oh, yeah, for sure.
Yeah.
Exactly what you see on the screen right now. You wouldn't, most problems you're not going to have to do it twice from both acute angles, but yeah, I want the arrow through it to show which side is opposite, definitely. All right. Now we are going to do the exact same thing, same picture. So you're going to label your O, A's, and H's exactly the same manner from L and H. But now we're going to be looking at cosine. So remember, cosine requires you to look at two different sides. Cosine is the K part of SOHCAHTOA. So you're spelling that C-A-H. So remember, cosine, you only look at adjacent and hypotenuse. So in this case, from angle L, the adjacent side is 12, whereas the hypotenuse is still 13. So we have 12 to 13. For angle H, remember the opposite side became 12 and the adjacent side became 5. So now cosine, from the point of view of angle H, is going to be 5 to 13. Again, two very different answers.
But did you notice that when you look at sine and look at cosine, look at your answers. Like, look at sine of L, cosine of L. Then look at sine of H and cosine of H. Notice anything?
Maybe. We'll come back to that in a second.
Hmm.
Think about it. All right, and then we're also going to have you kind of think about this one as well when you come up with the answer. So again, third time you've had this same picture, so labeling it shouldn't be an issue. From angle L, we have our O, A, and H written on the 5, 12, and 13. Remember SOHCAHTOA. Now we're on the TOA part, spelled T-O-A. So tangent, you only look at opposite adjacent. So opposite angle L is side HS down here 5. And then the adjacent side is this 12. So our tangent of angle L is going to be 5 over 12. Then we look at angle H, opposite only and adjacent only. You're going to write 12 over 5. Again, look at your answers for tangent. There should be something you're noticing. So you guys don't have a specific place where you're going to be writing this down, but it's the observations that we're wanting you to notice. If you look at sine of L and sine of H and cosine of L and cosine of H, you should see that we have the same two ratios being repeated. What was sine of L equal to?
5 over 13.
And what was cosine of H equal to?
5 over 13.
There you go. And then sine of H and cosine of L were both
12 over 13.
Okay. What is the relationship between angle L and angle H based on the fact that we have a right triangle? What do we know about angle L and angle H?
Okay, so I got to think here. So I have a triangle, which means I know all three angles are 180 degrees when I put them all together. But then I've got that 90-degree angle, okay, whatever. So we take that one out, and the other two angles are 90 degrees.
There you go. So angle L and angle H are going to be complementary angles. They add up to 90. That is always going to be true when we're dealing with right triangles because as Mrs. Nett said, you have a triangle, which means they add up to 180, and it's a right triangle, so the one angle is always 90, which means the other two have to be 90. So some important things you need to write down, and you're going to write them down either at the bottom of your notes or along the side. Somewhere you need to be writing this down. Sine and cosine of complementary angles are always equal. So the first bullet point is bringing home what we were just talking about. The sine of L was equal to cosine of H. Well, L and H are complementary. So sine and cosine of complementary angles are always equal. That's written in words. The second bullet point, I have this. These mean the same thing. I just wrote it as an equation versus words. So sine of theta, we know theta represents some angle. We know the other angle we would look at would be the complementary angle. Well, if theta is 30, what's 90 minus 30?
60 degrees.
So sine of 30 would be equal to cosine of 60.
That makes total sense.
So sometimes you may see it written this way. Honors, I know you will see it written this way, so make sure you understand what this is talking about. Again, sine and cosine are equal when you have one angle and then its complementary angle in the other spot. Down here, hopefully you notice this as well. Tangents of complementary angles are always reciprocals. The tangent of L was 5 over 12. Well, the tangent of H was the reciprocal of that, so 12 over 5. So tangent of some angle theta, well, this is technically tangent over 1. What's the reciprocal of tangent over 1? 1 over tangent. So tangent of an angle is equal to the reciprocal of its complementary angle. So please make sure, pause this video, get this stuff written down, know this. This is tested, but all on a chapter, a final, and a state test level. You need to know these two relationships. Sine, cosine of complementary angles are equal, and tangents of complementary angles are reciprocals. So that's an important thing to know.
And I also heard it's pretty much all over the SAT.
There you go. All right. So now we're actually going to solve some of these. So first thing I need you guys to look at is, or to remember, when you're working with right triangles, they're not going to necessarily say, hey, you have to use trigonometry. So it's important to notice, when will you use trigonometry? You will use Pythagorean theorem again when you know two sides and you're looking for a third side. You will use trigonometry when you're working with two sides and one angle. You can have a missing side or a missing angle, it doesn't matter, but it's going to be two sides and an angle. You can see in the picture on the screen that we have a 41-degree angle, and we have the side 24, and then you have side x.
Oh my gosh, that was not good.
No. Sorry for that bang.
Scared us.
Bad.
Bad. Mr. Knight thought he'd be just absolutely funny, and while we were recording, come try to bang down the door and scare us. And
yes, so I don't even remember what I was saying, honestly. Okay,
yeah, I'd like to give him a sign.
Anyway. Okay, anyways, this is going to be a trigonometry problem based on the fact that you only know one side and one angle. So we're going to go ahead and write down SOHCAHTOA. Somewhere on here. Oh, it's down here. Okay. Yeah. Got it. Okay. So anyways, now we're going to start labeling our opposite, adjacent, and hypotenuse side. I recommend, again, always starting with the hypotenuse. So here's our right angle. Therefore, this is our hypotenuse. There are two different types of problems that you're going to see. One of them is going to be that you are going to give us all trig functions that could be used to solve for whatever we're looking for, in this case, x. When you are asked to give us all trig functions, you are required to give us the trig function using the 41 degrees. And then you are also going to need to calculate what this angle over here, which we know is the complement of 41. So that would be, what, 49? So you would have to tell me the trig function we would use using the 49 here.
Easy.
That's one of the types of questions. The other one is like this, where it just says solve for x, or find the missing side length. So when you're asked to do this, I would recommend just using the angle you're given, in this case 41. So from 41 degrees, you're going to label your opposite and adjacent side. So remember, 41 is going to point to that opposite side, leaving you the third side, or the second leg, your adjacent side. Now you guys have to determine which trig function is going to be used to solve it using the 41-degree angle. A couple different ways you can look at this. I like to look at the fact that A has nothing there next to it to plug in for A, like we were doing in the first three problems in this lesson. Whereas for opposite, I can plug X in, and for hypotenuse, I can plug 24 in. So if you look at SOHCAHTOA, here's how I was recommending you guys write it. You're going to be looking for the trig function that uses opposite and hypotenuse and does not use adjacent at all.
So basically, after you label your OH and your A, you need to look at your triangle and look what was already there on the problem. So if you look over on the A side, there's nothing there. They gave us nothing. So you're not going to use any of the trig functions that have an A in it.
So cosine and tangent are out.
Has to be sine.
So this has to be a sine problem. So if this is going to be a sine problem, we're going to now write down our equation. If you need to flip your notes back over and look at what I said was kind of like the formula for sine, you can do that. It says sine of theta is equal to opposite divided by hypotenuse. Well, theta in this case is going to be that 41 degrees. Opposite, you're going to plug x in, and hypotenuse, you're going to plug 24 in. So you are going to get this equation here. Sine of 41 is equal to x over 24. After you get to this step, you're going to treat this just like a proportion. Sine of 41 is not over anything right now, so we can go ahead and put it over 1. And we're just going to start cross multiplying. 1 times x and 24 times sine of 41. I have a very important thing to say as far as calculator use. I strongly recommend that you get in the habit of writing it in this order, because if you type sine 41 times 24, there's a chance that your calculator will do the multiplication of 41 times 24 before it takes the sign of the number. That would be the incorrect order of operations, giving you an incorrect answer.
Unless you have sine 41 in parentheses and then after that 24. So you can't do sine 41 times 24 with no parentheses. That won't work.
So the easiest thing I suggest, separate the numbers by the trig function you're using. So you could even type in your calculator without parentheses this way. You could do 24 sine 41 and get the right answer.
Yep.
Or you can hit 24 and then the times button, sine 41. Or you can type it literally just like this with parentheses. You should be getting, if you type that in your calculator correctly, that this length would be approximately 15.75. If you are not getting the correct answer, please remember you may need to check the settings on your calculator. You should be in degree mode for angles. So double check it if you did not get a right answer. If you are in the right mode and did not get the right answer, double check with your teacher as soon as possible. All right, moving on. Again, this is going to be a trigonometry problem based on the fact that you have one side, one angle. You're looking for a side. So we need to label our opposite, adjacent, and hypotenuse sides. So x is going to be the hypotenuse. Because I'm just looking for x, I'm going to use the 65-degree angle, which creates this bottom is our opposite side, and then the vertical side is adjacent. So because I can see that adjacent will be plugged in with 12, and hypotenuse we're going to plug in x, nothing for opposite, that leaves sine and tangent to be out of the running for which one we're going to pick. We're plugging in a and h, so this is a cosine problem. So cosine of theta is always equal to adjacent over hypotenuse. In this case, theta will be 65, adjacent will be 12, and hypotenuse will be x. So there is our equation. Working through the motions, again, cosine of 65 can be made into a fraction. And now we're going to cross multiply. So cross multiplying here is going to give us this equation. If you were to solve an equation that was just 65x equals 12, you would just divide the 65 out. Well, this is no different. You just have to remember that cosine is attached to that 65. Because the cosine 65 is being multiplied to x, we're now going to simply divide it out. The cosines of 65 will cancel out on the left side, leaving you with 12 over cosine of 65 on the right side. In your calculator, you are simply going to type it just like that. If you do a fraction, please make sure there are parentheses around the cosine of 65. I prefer you just to treat this as a division problem though. 12 divided by cosine of 65, you should be getting an answer of approximately 28.39.
Easy. One more to go.
And then lastly, again, a trigonometry problem. So let's go ahead and label everything. Here's our right angle. Right angle is always going to point to our hypotenuse. Because I'm just finding one side length, I can go ahead and use 14 degrees, which is going to point opposite is our x side, and 12 is our adjacent side. So because we're using opposite adjacent, that's going to fall under the tangent ratio. We cannot use sine or cosine because both of them require me to know what the hypotenuse is. So our equation is going to be tangent of 14 is equal to opposite over adjacent, so x over 12. Going through the motions again, this is going to be a proportion, so we're going to multiply 12 times the tangent of 14, which is approximately 2.99. And there you have it. So hopefully you guys feel confident in your rating system here as to determining which trigonometric ratio you are going to use based on different given information. If at any time you have any questions, as always, reach out to Mrs. Netz, myself, or your teacher.
Hey, Mrs. Weichel.
Hey, what, Miss Nets?
So, I've been trying to get in shape. You?
Oh, yeah, I have a cruise coming up,
Yeah, me too. But I'm kind of really sad
Why?
because the only reason I ever taught geometry was because I heard it would get you in shape.
Geometry teachers are the most in shape teachers.
One would think so.
If only that were true. Everybody would want to teach this.
Yeah, well, or most probably should teach it.
There you go.
Ouch.
That was a burn. Who are you talking about? No, I'm just kidding. All right, thank you so much for joining us. We're really excited about this chapter, so we will talk to you in 7.2.